Okay, today I'm going to show you how to do empirical formula. Empirical formula, they're not hard, they're easy. So I'm going to show you how you guys should do them. I know a lot of people explain it to kind of make it so tough. So I'm going to say them because you might guys not see them really well. So we have 70.00% carbon, and we got 3.36% hydrogen, and we get 26.64% oxygen. These are by mass. Okay, what we mean by mass, we have to we have to be in grams. So now we have them in percentage, we need them in grams, and all these numbers have to equal to 100. So what I do is I try to add them all together, see if they make up 200. If they do, it means I do have the right percentage. So we have 100. So altogether have to be equal to 100, not more and even less. So after we make sure we have the right percentage, the next thing you should do is we have to convert these to grams. So you don't have to multiply by anything, just make it in your head. So because it equals the same number. So 70 equals 70 grams, 80 equals 80 grams, 72.4 equal to, percentage equal to 72.4 grams. So number equal itself. So we got 70 grams carbon, 3.36 hydrogen, and 26.64 oxygen. Okay. All these we have to start doing the calculation. The calculation is we put 70.00 gram carbon times, make a dash. So something have to be in right here in the numerator and something in the denominator. So what we should put on top is moles, because we're trying to convert to moles. So I got that bridge I've been taught to do so. So I'm going to show you how it goes. It goes right here, grams. Okay, it goes like a rainbow going up. We got moles. Go down. We got molecule. So we are here. Now we are here, right here. So where we should go to moles. Okay, so moles right here, 1 mole of what? Of carbon. And then in the bottom, we go on the periodic table. We look at the carbon. Carbon, it says 12.0107 gram AMU of carbon. So atomic mass. So we got 12.0107 grams of C. We divide these together, multiply by 1. You don't have to multiply by 1 because it's going to be itself, but that's how it goes. Because right here we cancel the grams. We left off with what? Mole. So 70. I'm going to use my calculator. Divided by 12.0107. And I like to use all the digits. That way we have an accurate answer. And press enter. I have 5.828. We're using like 4 significant things, so I'm gonna put 4 of them, so 5.8. So 5.828. 5.828 the answer for mole of gram of course carbon. I mean, sorry, couldn't complicate it right. So we got 3.36. Same thing we do with hydrogen. So now it's going to be like faster than the top one, hydrogen. We look at hydrogen. I should say 1.000794 hydrogen equal to the answer. So 3.36 divided by 1.0079, because it's not always 1. So we have decimals. 3, this, so 3.3333, so I'm going to put 4 of the 3's and mole of what? Hydrogen. And then we got the last one is oxygen, 26.64 oxygen, grams of oxygen, got 1 mole of oxygen. And the bottom one is how many oxygen we have? In single one, so it's 15.9994 grams of what? Of oxygen. That way we cancel the grams and we left out mole. So we divide 26.64 by what? By 15.994 grams of oxygen, and we left up 665 mole of what? Of oxygen. So right now we have all the numbers converted to what? To moles. What's the next step, do you think? What's the next step? The next step, it's usually look at the numbers. We got 5, 8.28, 3.333, and we got 1.6667. Can you like can you guys like wait, 5.8. Now we divide those numbers by what? By the least one. Which one the least one? 1.6667 mole of oxygen. It's the least one of those 3 numbers. So now I'm gonna divide each number by the number I choose, which is 1.665. So 5.8288 divided by 1.665. So the first mole of carbon give me what? Give me number. It's number 3.50. That's for carbon. And for hydrogen, okay, they give us, so 3.333 divided by 1.665, it gives me 2.00. And for carbon, it's going to be giving me 1 because I'm dividing it by the same number. So what? Because I have a decimal. I still have decimals. How I'm gonna get rid of these decimals? If I multiply this by itself times 2, if I add this by 2, if I add 2 3.550, I'm gonna get rid of the decimals. If I multiply it by 3, like 350, 350, 350, it's gonna be still. I'm gonna see what? I'm gonna see the number, the decimal again in my numbers. If I multiply it by 4, it's gonna give me non-decimal. But what's the least one? The least numbers. I don't want to make my numbers huge, so I'm gonna multiply this by 2. But this is gonna be big, and all these numbers are equal to each other. So if we add these all together, it gives us one number, like the 100%. When we added all the percentage, it gave us 100%. So each one has to be multiplied by 2 also. Not so the rest will be sad. I'm like, why she get 2, we don't get 2? So we have to multiply all of them. So first one we get 7, the next one we get 4, and the last one we get 2. So now what we see is we write the formula now. So we get C7, which is carbon 7, H4, okay, and then oxygen 2. So the formula is CHO, so CH7H4O2. So I'm gonna show you guys what I did. We had a percentage. We convert these to grams. Then we multiply. We try to see in the periodic table how much grams in each carbon, and then we get 5.828 moles carbon. Same thing with hydrogen. Same thing with oxygen. Then we look at the least number from these numbers right here. It's 1.6665 moles oxygen. After that, if you have decimals. If you don't have decimals, you're okay, you're fine. But if you have decimals, how are we gonna get rid of decimals? So we multiply this by itself. So 3.50 gives us 7. That's a whole number. But if we multiply this number by 3 times, it's going to give us again a decimal number. So we're like in stuck. We're just going around and around with the circle. So we're not trying to get out of the circle. So we're still in the circle. So we're trying to get out of the circle. So whole number, whole number, whole number. Thank you. That's an empirical.